Good morning. If you are just joining us this morning, we'll get started here in just about 2 minutes. We're waiting for some more folks to sign on. So stay tuned, please. Thank you so much. Good morning. If you're just joining us this morning, we're going to get started in just about 1 minute. We'll start the program in just about 1 minute. Thank you so much. Good morning, everyone. My name is Will Tapia, and I am the Advancement Coordinator for Big Brothers Big Sisters. Good morning. We are so happy that you're here joining us this morning for our virtual Discovery Festival. This is so exciting. I'm going to just real quick explain kind of what Discovery Festival has been, and then, of course, what it's looking like this year. So Discovery Festival normally is a one-day event that Big Brothers Big Sisters hosts at the Albuquerque Convention Center. We have 50 plus exhibitors, all from various areas of STEAM, which of course means science, technology, engineering, art, and mathematics, and all these incredible hands-on experiments where you, the students, can get an idea for what STEAM is in New Mexico and know that, hey, there's schooling in New Mexico for STEAM. You don't have to leave the state. And there's also job and career opportunities in New Mexico in STEAM. So we're really excited about that. Normally we get about 3,000 students, so it's amazing. But obviously this year, as we all know, due to the novel COVID-19 pandemic, we've all had to, unfortunately, not be in person this year as much. So as a result, this is how you see us this morning today in our virtual Discovery Festival STEAM fair. So we're, again, just so excited you're here. We have close to 5,000 students registered all across the state of New Mexico, all here to participate in our STEAM event. Don't forget, we extended the deadline to this Friday the 13th to submit your STEAM, your STEM Fair and Art Expo experiment. Everyone who enters, every single student who enters is entered into a raffle to win the new Xbox Series S. We have amazing prizes too, first place, second place, third place, from party passes at a trampoline park, to all kinds of fantastic stuff. So we're really excited about that. So take a look at our website, discoveryfestnm.org. We'll post it in the chat, in the YouTube chat. You can take a look at that there. Speaking of the chat, I see you guys are all using the chat already. That's awesome to see. So inside that chat on YouTube, if you have a question at any point during the presentation, ask it in that chat. Type it in the chat, and we'll be sure to ask it live on the program. I'll pop in and interrupt our presenter and ask all those questions. Tell us where you're from, all this kind of great stuff, and we will mention it live on the program. Super excited about that. So real quick, before we jump into the rest of the program, I wanted to give a shout out. We have some amazing sponsors for our virtual Discovery Festival this year. So keep an eye out for these guys. They're going to present here in the next couple of weeks. We have Honeywell. Honeywell is an awesome partner of ours. For any of you who went last year, you know Honeywell. was a big sponsor and presenter at last year's in-person Discovery Festival. So they're coming back. They're coming back with a series of awesome videos and awesome experiments for you. So stay tuned for Honeywell. Thank you so much for your sponsorship there, Honeywell. To our Curie sponsor, Fidelity Investments, who will be on later today. So stay tuned. Come back at 1 p.m. today to see Fidelity Investments presentation. It should be amazing. They always have incredible stuff. If you want to learn more about money, what money is, especially now during this crazy time that we're in, this is a great presentation for you. You will absolutely love it. They have lots of fun take-home things as well for you. So to our ride sponsors, Aztec Machine and Repair out in beautiful Bloomfield, New Mexico. Thank you so much, Aztec. To Air Force Research Laboratories, they're coming on next week, which is going to be awesome. They're going to be presenting on paper satellites. So if you like satellites, if you like space and all the amazing stuff that they have to offer, check out Air Force Research Laboratories next week. Also, to our Newton sponsors, we have the Defense Threat Reduction Agency, or as we like to call them, DTRA. Thank you so much, DTRA. They're coming on as well next week, so stay tuned for them. Micronet Solutions, Sandia National Labs, who we have a guest on today from Sandia. Super excited about that. And a Presbyterian. Thank you so much to all of our Newton sponsors. And it's our general shout out page here. So thank you so much to all our sponsors. Okay, so with all that stuff out of the way, as you see here, I have a special guest today. Super excited about it. And I think you all will be too. So don't forget to use that chat on YouTube. That's how we're going to get your questions answered live. There's a couple of portions where our guest is going to ask you for your questions and your feedback and all this kind of stuff. So use that chat. That's why it's there. So our special guest for today is Sandia National Laboratories. Very excited to have them here. And we have Alex Chen, a bona fide scientist at Sandia. Alex, do we have you there?
Hi, can you hear me?
Awesome, Alex. We got you loud and clear. Without further ado, I think the kids are tired of hearing me talk. So Alex, I'm going to pass it over to you.
Okay.
Alrighty.
Well, hi, everyone. As Will said, I'm Alex, and I'd really like to thank Big Brothers, Big Sisters for organizing this event and letting us present about science. So today, we're going to talk a little bit about what Sandia National Labs is, what experiments we might be doing there, and then we're going to talk about solids, liquids, and gases, and how it relates to the science we do at Sandia. So let's first watch a short video on Sandia National Laboratories. All right. So as we can see, Sandia National Labs here in Albuquerque, New Mexico was founded in 1945, which was 75 years ago. So what types of experiments did we see in those videos? Did you guys see rocket launches? Did you guys see the train crash test? So why are we doing these types of experiments? So these experiments are important so we can understand what would happen in the real world. So did you see some of those computer simulations during the video? As we can see, like here, we can see some computer graphics that kind of are simulating the physical world. And so why are these important? So we want to have some simulations or virtually conduct these experiments in the computer so we can compare the results to what we see in the real world so we can validate our hypothesis, which is our best guess based on our knowledge of science and math. And so Sandia also researches the climate, weather patterns, nuclear power and weapons, and many other cool experiments. So one of the cool experiments that we saw very briefly was the solar tower. And I'd like to show you guys another video. But before we talk about that, if you've ever flown into Albuquerque or been flying out or just seen the area from the mountains, you might have noticed a really tall tower in the distance. And that is the solar tower on Sandia National Labs campus. And what happens here is we take different materials and we heat them up with these mirrors. But let's watch this video and see what actually happens. So we can see here.
Okay, going to offset. 10-4. Seconds. Going to line top. 10-4.
So we can see something's happening here, but we're not so sure yet. So I think the scientists here are taking this plastic sheet of material and they're loading it into this stand so that they can hold it still. And now they're raising up the material to face the mirrors that are down below.
5, 4,
and let's see what happens.
3, 2, 1. Going on.
It's starting to heat up a lot. Wow. So you can see the mirrors down there are doing something to heat this surface, this plastic up, and it's starting to burn up. So what do we think is happening here? So have you guys ever played with, say, like a reflective material like a mirror or something shiny and just looked at the sun and kind of reflected it towards the wall and see like a piece of light there? So this is kind of similar to what we're doing here. And we're taking curved shiny surfaces, these mirrors, they're called parabolic mirrors, and we aim them at this material while reflecting the sunlight, and we can focus all this heat and all this light energy towards the object and heat it up really quickly. So here we can see some thermal cameras looking at the material and seeing how it's heating up, how quickly it's heating up, and what's happening to the material as it's melting. And so it's pretty wild. So now they're going to experiment with a piñon tree and see what happens when they mount it. What do you guys think is going to happen? So did you see all the light concentrate on the tree? all of a sudden, and all that light heats up the tree so much that it starts to ignite and catch on fire. And so this is just an example of some of the science experiments that we do here at Sandia. And so why might you say, oh, why do we need to like test this? Like how useful is this setup? So a great example of this in the real world is, say, for instance, the space shuttle, which is a reusable rocket ship that we used to use to send astronauts into space. And when the space shuttle comes back in for landing, the heat tiles on the bottom of the space shuttle get really, really hot. So just like when you rub your hands together really fast and you feel heat between your hands, that's friction causing the heat. So just like when the space shuttle is coming in, the airflow underneath that's hitting that air tile is heating up those heat tiles really, really hot. So say, for example, we wanted to test how hot the heat tile could get. We could mount it on the solar tower and we could heat it up to a temperature and see if it survives. So that's just a real world example of testing a material. So can you guys think of any other examples of why we'd want to heat something up and see if it survives? So just let me know and we can talk about it when due.
Well, we do have
So
some questions, Alex, if I
yeah,
could
sure.
jump in here. So first up, I see the chat is super active, so this is awesome. They really got a big kick out of the mirrors and everything, so it's very cool. I wanted to give a shout out to some of our schools who are on. It looks like we have Osuna Elementary, Lowell Elementary, Aspen, 6th grade. We have some folks out in Shiprock who are on right now, Dennis Chavez Elementary who are on. And then as you were asking about their observations, one student commented that he thinks it's concentrated energy that, of course, is being generated from the sun. So that was a really cool observation. We did get a question from Caleb. Caleb's asking, how many mirrors do you need to do something like this?
So you need it just depends on how hot you want your object to get and how big it is. Because say, for instance, I take a little mirror, I could make a little tiny pinprick of light on the ground and maybe, heat something up that way. And you guys can even look this up and try this with your parents. They're called solar ovens. And you can use tin foil and other reflective surfaces to even bake cookies at home on like a hot day where the sun is really strong. So, but for this Christmas tree, if we wanted to make it, light on fire really, really quickly, we'd need a lot of mirrors so we can have a lot of energy. And so we can see in the video that there's, probably around like 40 or 50 mirrors that are aimed towards the tree. But for each experiment, they can control how many mirrors they want to point at it. So it just depends on how big of an object and how quickly they want to get it to be hot.
And we did get another question as well. So the student is asking, what's behind the tree?
So there's some reflective material behind the tree to just protect the equipment. It's not helping ignite the tree perhaps, because if you look at the video, only the front side of the tree gets really bright because all the mirrors are focusing their energy right there.
Awesome. Hunter wants to know, what other things have you tested this with?
So there's other materials that we want to get super hot. Like for instance, like I talked about the space shuttle just for like a little bit ago. Like if we wanted to heat up like different paint, like say we were flying in an airplane or something, and we know that the paint might get kind of hot from the friction, from the airflow, or from the sun or other exposure. We might want to just test that really quickly and see if the paint will survive, or just other materials that we see get really hot. Like for instance, like a mundane example would be like, what if we wanted to test a new type of cookware, or like a large pot that we know for another experiment we got to heat it up to like 1,000 degrees or something. So we could use these mirrors to heat it up really quickly.
And Robert wants to know what material you use for the mirrors.
I am not 100% sure what material we use for the mirrors. I just know that they are highly polished, reflective, I think some sort of metallic glass combination. But I'm sorry, I don't know that answer. I personally don't work at the solar tower, but I have taken a tour, and it is very, very tall and very cool. So
Awesome. Okay. We're getting a lot of questions. Sorry, Alex, but
no, I like the questions.
awesome. Yeah. Nathan is wondering if this could be utilized for future weapon or equipment technology that can be used in experiments or other projects.
Sure. Yeah. For instance, like, say we wanted, like, the main objective is to see like how these materials react to all this heat, right? So for instance, like, what if we wanted to take the temperature inside the material without destroying our temperature thermometer, right? Like, so for instance, like, we coat it with something special that we make at the labs, and then we put a bunch of heat at it and then see if it will survive. And if we apply too much heat and the thermometer breaks, then we know that our material that we coated that thermometer with to protect it isn't good enough. So that would be a good example of like something we might try to do here at the labs.
Awesome. And then a student from Miss Harbaugh's class would like to know if Sandia works with NASA.
Sandia actually does work with NASA. Back during the space shuttle times, we did a lot of research with them on the space shuttle and reentry and different accidents, like the tragic accident when the Columbia space shuttle, I believe, and re-entered the atmosphere. And Sandia helped NASA conduct an investigative experiment and reports to see what was the cause of the accident and other things like that. So we do work with NASA, and they are a great partner.
And Christopher wants to know how hot these materials get.
So again, it just depends on how many mirrors we are pointing at these objects, but they could get up to like thousands of degrees.
Wow. Tiffany from Miss Harbaugh's class would like to know if you've ever tested metal.
Yes. So I believe they've tested some metals just to see how they will react to heat, because, you know, sometimes we're putting materials in extreme conditions, like really high heat, high pressure environments. So yes, we've put blocks of metal out there and just tried to melt them and see what happens.
And Nathan's got a good question here. He says, is it possible to also use this for aircraft technology that can consist of military aircraft and space aircraft? Could this be necessary for civilian aircrafts?
For instance, like, there are some recent projects that are being done by private companies, such as like Boom Aerospace. I'm just speaking theoretically. I'm not 100% sure, but like, say if we have a supersonic jet by Boom Aerospace going around, and we know that their material on the outside of the plane is heating up really quickly, then they might ask Sandia to do some testing. I'm just making this example up as an example of what we could do, but I personally don't know about like any partnerships or anything, because I don't work at the solar tower. But that is a really good question.
Awesome. And we'll just take a couple more questions so you can continue on. We're getting a lot of a lot of very active chat here. So,
Sure.
let's see here. We'll do from Ms. Young's class. Alea wants to know how long did it take for the mirrors to catch the tree on fire?
So we can just watch the video again, and I believe at the beginning of the video, the plastic sheet, they only exposed it for 5 seconds. I'm not 100% sure about the tree, but I think they're only exposing it for a couple seconds. And then do you see how quickly it catches on fire? So this is in real time. It's not slowed down or sped up. So like, I think in about like 2 seconds, the mirrors just got it on fire.
Wow, amazing. Okay, well, it's great. Like I said, we're having a really active chat, so keep the chat going if you have questions, and we'll let Alex continue with his presentation, and then we'll jump in here at the end with more questions. Thanks, Alex.
Okay. Well, so let me stop screen sharing for a second, and so I can just see myself. So why do we want to understand science? So we want to understand science because it helps us understand the real world around us and how things are interacting with like heat, like for instance, like how the tree was catching on fire and how quickly it was catching on fire. And so to work at Sandia and do these kinds of cool experiments, we have to first understand like our basic science. So we have to understand first our states of matter. So solids, liquids, and gases. So take a second, and if you're at home, maybe just write down or like try to find little objects around you or something that can represent a solid and a liquid and a gas. And I'll do the same really quickly. So I found some marbles here. And so we can see that they're a solid because they have a definite shape and size. So this one is a sphere, and it doesn't, I can't really easily change its shape and size here. And then for liquid, I have some water here, and we know that it is liquid because it has a definite volume. See, it takes up this water bottle, but it doesn't have a definite shape because I can pour it in a different shape here. So like this cup right here, and it takes up the shape of this right here. Now for a gas, I found a balloon, but you could as easily just use your hands and try to, let's see if we can try to catch this gas. If I blow onto my hands, I can't catch it, right? Because gas doesn't have a definite shape or volume. It just takes up whatever it's containing it. So like we take this balloon, and I fill it up with my breath, which is a gas made of carbon dioxide and other gases. And we fill up the balloon, and we can see it just takes up the volume here. So solids, liquids, and gases are all around us, and we want to classify them so we can easily understand and describe their behavior and interactions with each other. So now that we know a little more, let me share my screen and let's do an experiment that I've pre-recorded. So let's take this.
Hi everyone, it's Alex here with Sandia National Laboratories. Now that we've learned about the three states of matter, which are solids, liquids, and gases, let's do a fun experiment that showcases these states of matters. So for this experiment, we'll need some things that you might be able to find at home, which is baking soda, vinegar, an empty water bottle or soda can, some party balloons, some food coloring, and a funnel. So first, we're going to make sure that our water bottle is empty and clean because we don't want any residues contaminating our experiment. So we're going to take our funnel, and we're going to take our vinegar, and we're going to carefully pour some into our bottle, making sure not to fill it more than a quarter way full. So we're going to pour some vinegar in, and I think that's about it. So we're going to take some food coloring so we can see our reaction a little bit better. So we're going to drop some food coloring in here. Just a few drops should do the trick. And let's mix up our vinegar. And so now we can see we have some yellow orangish colored vinegar. We're going to put that to the side, and now we're going to prepare with our funnel and a balloon some baking soda for our experiment. So let's take our balloon, and we're going to stretch it out and place it over the end of the funnel. And then we're going to take our solid, which is our baking soda, and we're going to take some, which we only need about a little bit less than a spoonful. We're going to carefully put it in our balloon with the funnel. So we're going to make sure the baking soda is in the bottom of the balloon, and we're going to take our baking soda balloon and place it carefully over the edge of the bottle. So now we have our liquid, which is our vinegar, our solid, which is our baking soda, and we're going to combine them and see what happens. Let's pause the video and make some predictions.
All right, so I know there's a little bit of lag between our presentation of experiment and the questions that are going to come in. So let's just take a second and let's write down what we think is going to happen. And some of you may have seen this experiment before, but let's just see what happens. So back to the video.
Hi, so now that we're back, let's combine our solid, which is our baking soda, our liquid, which is our vinegar, and see what happens. When we do this, let's make sure to hold our experiment so it doesn't fall over. Oh my gosh, look at that. The balloon is expanding with the gas created by the reaction between the baking soda and the vinegar. And it has filled up the balloon. Thanks for watching.
So as we saw there in that experiment, that we combined the baking soda and vinegar and created a reaction to create gas. And so for some of our older members, I'll explain it in more detailed terms. So when the vinegar and baking soda are mixed together, the hydrogen ions in the vinegar react with the sodium and bicarbonate ions in the baking soda. So this reaction creates carbonic acid and sodium acetate. And so when this happens, there's an offset of gas, and that fills up the balloon with this reaction. And so there we saw the solid, the liquid, and the gas in that experiment. And if we have any questions, Will, do we have anything in the chat right now?
We do. So we got a lot of great predictions that were right on the money. Let's see here. What other questions do we have? Yeah, the chat is firing off there, so I'll have to keep an eye on it. But yeah, we have had a lot of positive feedback to your experiment, Alex.
Okay. Well, we have one more quick experiment to show, and we'll watch this video.
Go ahead. We did get a question just now.
Sure.
So, Robert wants to know if you have to dump the balloon into the bottle or if you can dump the vinegar into the balloon.
So you could dump the vinegar into the balloon, but then that risks the balloon just popping off, because when I'm dumping the baking soda into the vinegar, I'm kind of controlling the reaction by slowly putting some baking soda into the vinegar. But yeah, you're right. You could just flip it upside down. And the reason why I said carefully do this is because on a previous take of the video, I actually did spill the experiment everywhere. So do be careful.
And we got another question here asking, how does everything combine together?
So I guess in simpler terms, when the baking soda hits the vinegar, the ions in each material are kind of attracted to each other, and they want to form different things together because they just are attracted that way. And so when the vinegar starts to dissolve the baking soda, we see a reaction that creates this carbonic acid and sodium acetate, which makes this gas form. Just like when you're mixing different materials together, like when you're cooking, like when you're mixing water and flour, you start to get this dough instead of just two distinct materials, right?
Great. It looks like that might be the questions for now.
Okay, so let's move on to a really quick short video about another experiment.
Hi everyone, it's Alex again here with Sandia National Laboratories. Now that we know even more about solids, liquids, and gases, let's do an experiment with dry ice and some water. So for this experiment, we're going to need some safety gloves, as dry ice is very, very cold, and it is currently at around negative 110 degrees Fahrenheit, which is very, very cold. As we know that water freezes at 32 degrees Fahrenheit. So you can get some dry ice with your parents' permission at a grocery store, but let them handle it as it is very cold and we need to be extra careful. So we're going to take some dry ice, and right now it's in solid form, and we're going to put it here in this cup, and we can see that there's a little block of dry ice, and it is a solid right now. And we're going to take our liquid water here, which is at room temperature, which is around 75 degrees Fahrenheit, and put it on our block of dry ice.
let's pause the video here and
so we'll
let's
take a
think
break here
about
again
what's going
and
to happen.
just let's write down our prediction about what's going to happen when we take our really cold dry ice and combine it with water. And let's think about it. And let's watch the video.
Hi everyone, we're back. And we're going to put our liquid water over our solid carbon dioxide, which is also known as dry ice, and see what happens. Wow, look at that. It is making a gas. The dry ice is undergoing a process known as sublimation, which means that instead of going from a solid to a liquid, such as when ice melts in your hand, it is going directly from a solid to a gas, which you can see happening right now. So it's pretty cool. As you can see, the gas is just coming right out of our experiment. Thanks for watching.
Again, just to be clear, the process of sublimation is when we're going directly from the solid to the gas. So the carbon dioxide reacting with the room temperature water is melting so quickly. It's not even melting, it's just going straight to that gas phase. So all that white smoke that we see, that's carbon dioxide, which is similar to the gas that we're breathing out when we, breathe in and out. So if we have any questions about that, or any of the experiments or any of the videos, I'm happy to answer those.
Yep, we do have a question. So Caleb wants to know, why is it called dry ice?
So it is just the scientist who came up with the the dry ice. It just called it dry ice because he was like, wow, it's not ice. It seems kind of dry because it's not like melting when I touch it. So he just coined the term. And so if you also come up with something cool like that, you can also name it whatever you want.
We got another question about what is dry ice?
So dry ice, I'm briefly mentioned in the video, but like let's go into a little more detail. So dry ice is frozen carbon dioxide. It's solid carbon dioxide, which is created when we put in a gas and we compress it at a high pressure and a low temperature, and it starts to solidify and make these blocks of ice. And a lot of people use them every day to put in their ice cream cart to keep their ice cream cold, or you can put it in like a big punch bowl and make like gas come out for like a Halloween decoration. But you do have to be careful again when you handle it, as if you touch it with your bare skin, it can lead to cold burns. So do be careful when you handle it.
That's a great point, and I think leads us into our next question, asking why will dry ice give you frostbite, but regular ice will not?
So again, so regular ice over time can give you frostbite if you are just surrounded in like a big block of ice, right? But if you just hold an ice cube in your hand and you're just kind of playing with it, it's not really going to give you freezer burn or whatever, or like damage your skin, because it's not cold enough for long enough to damage that skin. But dry ice is at, I think I said, a negative 110 degrees Fahrenheit. So it's very, very cold, much colder than the ice is, which is at like, around 30, 32 degrees Fahrenheit. So because it's so much colder, it doesn't take as much time for it to damage your skin. Just like when we were looking at like the exact opposite, like when we were catching those trees on fire. Like if we just used one mirror to like focus a little beam of light on that tree, it would take a long time for it to start burning. But if we used a bunch of mirrors, like very quickly in 1 second or two, it started to catch on fire. So I know it almost sounds crazy and like opposites that I'm talking about fire and ice, but like very similar principle of like how much energy and for how long it takes. So very long-winded answer to your question.
Well, and I think on that, so Dustin wants to know, why does carbon dioxide with the dry ice go from the solid and it just totally skips the liquid phase and then goes right to the gas?
So it delves a little bit into the relationship between pressure and temperature. And so if we look at these graphs, I don't have any on hand, but there is actually something called the triple point, which at a certain temperature and pressure, something can exist at all three states of matter. So solid, at a solid, liquid, and a gas, which is just crazy. Like, how can that even happen? But because that this graph has these intersecting points, we don't always need to traverse from a solid to a liquid directly. At a certain temperature and pressure, which is available here when we poured the water on the dry ice can just go directly from the solid to the gas. And so there are other materials that do this, but it just requires a different temperature and pressure. Like, for instance, like we could do the same with like ice. Like, for instance, have you ever seen when you take ice out of the freezer and you see like a little smoke coming off, but the whole thing isn't just going up in smoke, right? It's just enough and just the right amount of like pressure and temperature to just have a little bit of it just go to a gas.
And so I guess kind of on that analogy that you just used, so can dry ice in that scenario be good to cool down a drink?
So you could cool a drink down with dry ice, but it would be very hard to drink it. As you saw, the dry ice was bubbling out. And so if you tried to drink it, you might, inhale a lot of carbon dioxide. So I would not recommend that. However, with your parents' permission, you could put it in a big bowl of punch or something, and but you would see bubbles of carbon dioxide come up and pop and release the gas. And you could use that to try to cool down your punch. But again, don't drink directly from the bowl and don't handle the dry ice directly with your bare skin.
And we did get, we got a couple of students who are really excited about the reaction video. So anyway, so that's awesome. Keep posting those questions in there and we'll let Alex take it back then. All
right, so I have another video to show you all just about another experiment at Sandia National Labs, and let's watch the video. So another thing we do at Sandia is work with robotics, and we know that they have many different applications. So let's just look at the video real quickly. So we can see the robotic hand able to grasp this big rock, and then now we're grasping like a little canteen here and placing it on a piece of paper. And this one's a little more tricky because these objects are getting smaller. So we're picking up this pipe here. And now, so let's think about what applications we want for this robotic hand. So like, what do we want to do with it? Do we want it to answer phone calls for us? I'm not sure, but the purpose of like testing these different objects is to see the capability of this robotic hand. Because, if I have a big, strong hand and it's able to, lift up a big rock like that, it's not useful for me if I'm working in a setting where I want the robot to like pick up a water bottle. And if it used the same force and pressure to pick up the water bottle as it did this like a big rock, then it would just squeeze it and it would go everywhere, right? And so we see that in this case, we're doing like a kind of more delicate maneuver where we're trying to pick up this phone without picking up the receiver. So in this task, if you've ever worked with suitcases or cases like this, you've got to pick it up by the handle. So that's another type of task and versatility that we're trying to demonstrate here. See how it just turned the flashlight on right there? That's, if we applied too much force, then you might just break the flashlight. and this one's pretty wild. So we see a flashlight here, and the robot's trying to pick up very gently this battery. And I think they're going to try to do something where they put it inside the flashlight. And this is pretty intense maneuvering. And I think right here they're picking up a really tiny key right here, which you think might be easy, but imagine trying to do it with this robotic hand. Oh, it dropped it. So right here, they're using a pair of wire snippers and they're trying to snip a wire. So for instance, if we were working in like a dangerous environment, like maybe there was a bomb or like something was on fire and we needed a robot to do something about it, then this robot might be capable enough to snip some wires and or defuse a bomb or something along the lines of that. So this is just an example of the technology that we have at Sandia and that we're working on. All right. I think, so originally we were going to have a virtual lab tour by another scientist here named Caroline, but unfortunately she actually had a real life experiment to go do, and so she could not come out here. But I am happy to answer any questions about anything at all, whether it's related to Sandia, to science, or going to college, or anything like that. And I'm just here to talk to you guys.
Well, we have had a bunch of questions come in. That was a very cool video. One question that Robert was wondering is if the fingers are attached to magnets.
So I believe that you saw the fingers were connected magnetically and they just placed them right there. And so that's super challenging because, you know, how are we going to tell the robot what to do? Like, how are we going to send these signals to them? So it is a very cool technological achievement to be able to put the fingers on and off just like that. Like, for instance, like, what is the use of doing that? So if, say, one of the fingers got damaged during picking something up, then we could quickly go in and just take one of those fingers off and put another one on and continue on with what we're doing.
And Jackson would like to know, how long does it take to make dry ice?
So you can make it. Sorry. I don't know. I don't think people, like regular people, can make it at home unless you had like a full chemistry lab setup. So you need like a big container that can handle really high pressures and be able to cool down the material really quickly. And so I think they do this process in like a factory. I myself have never seen the process of dry ice being made, but I believe it could take, you know, like maybe a night or a couple hours, just depends on how quickly they can cool it down.
And how is the robotic arm being controlled?
So if we look at the end of the video, I think that we can see, all right, well, never mind. But I think you can see that the robotic arm has some sensors. Like there was a kind of a head attached to where the arm was coming out, and then it had cameras and stuff like that. And so some of the actions may have been pre-programmed, like picking up those really big objects. But maybe some of those complex tasks, it just depends on what they've programmed in or not. Like maybe like trying to snip this wire here might require a little bit of human assistance there.
Scarlett wants to know if there are robots in homes.
So there are robots in homes. So for instance, so a robot is just like a machine that does work for you. And so a robot might not necessarily look like a mechanical version of a human with an arm or something. So like, for example, you know, those iRobots, like the little circular vacuum cleaners that you might have seen around or heard about that go around the home and just like vacuum the dirt off the floor. That is a robot because it's doing a task automatically for you. And so that's an example of a robot at home.
Awesome. Presley wants to know, how long does it take to build a robot?
So a robot like that could take many years to develop, especially because Sandia is working on technology that doesn't actually exist yet. We're on the cutting edge, like we're on the frontiers of science. So to make this happen, we both need to develop like the software, so like the code that controls the robot and the camera system that like sees the objects, and also the mechanical portion of the robot, like how do we make those fingers magnetically attach and deattach and have them still be able to communicate and talk to the software and the brains behind what's going on. So it could take years, but small robots can be developed, like say your like robot vacuum cleaner. Now that they know it exists and works, if we wanted to like make an improvement on it, it could take like a couple weeks to a couple months to just develop it.
Yeah, it looks like a lot of the students have Roombas in their homes. I'm seeing a lot of those comments come through.
Oh, really?
Yeah. Shai wants to know if it's hard to control the robot and the fingers.
So there's another example of a robot that surgeons use, and you guys could look it up. It's called the Da Vinci robot, and I've actually played with this in person before. It's nothing to do with Sandia. It's a machine that was developed by a bunch of doctors and engineers, and you wear these glasses that help you, like you look into these glasses that is a video feed, and you control the robot with your 3 fingers right here, because they're like little pincers that are doing little object maneuvers. So there's a cool video that you could watch. I think if you just search like Da Vinci robot sews a grape up. And so imagine like taking a grape and trying to making a little cut and then sewing it back together with just your regular hands. Like your fingers are pretty fat, and at least mine are. So if you use the Da Vinci robot, you can expertly control and like maneuver it and sew up the grape very, very carefully and easily. And so this machine is used every day today in like different surgeries. And that's an example of how easily you can control a robot. However, a robot like this, for example, since it's not specialized like the Da Vinci robot for surgery, it is like a more general robot hand that they're trying to test. Did you see how they were picking up the rocks, and then they tried to pick up a little key and tried to put a battery in there? So this might be a little more hard to control because the application is so wide. Like if you want something to do more things, it's harder for you to do that.
And so Kaleo is wondering, and if you take dry ice and you put normal ice with it, does the normal ice then become dry ice, or will it just all eventually melt?
So I was playing with it a lot after the video, and so I'll answer that question in a second. But when I put the dry ice in the water, eventually the water that's surrounding the dry ice starts to form regular ice around the dry ice, because the dry ice is so cold, right? So it's making the water around it just start to freeze. So if we put this ice cube on top of the dry ice, then we might start to see it like stick to the dry ice, but the water itself wouldn't become more dry ice. Like we couldn't make more dry ice by just adding regular ice.
And I on that, so if you take things like fruits, like an orange, like a grape, anything like that, will you be able to freeze those as well with the dry ice?
So I didn't show. I was planning on doing like a different experiment, but I didn't have the proper materials. But if you have like a thick container, like a big thick bowl or something that won't break if it freezes, probably like made of metal, and if you put the dry ice inside of it with some water, and you put like different objects in, like you could put a rubber band or a leaf or a fruit inside and just leave it in there and see what happens. Then eventually when you take it out, these things will become really hard. So if we put like, say, a banana peel or like, an orange, we know it's like kind of floppy, but when we take it out, it's going to be rock hard. But it's going to take a little bit of time for it to just freeze. Just as if you had put it in the regular freezer, but it would take it wouldn't take as long.
Awesome. Okay, we're going to just take a couple more questions here, folks. So Nathan wants to know, so, you talked a little bit about using a robot to do delicate stitching and things like that. So he wants to know, malfunctions can occur with medical AI. I was wondering what improvements were being made for that.
Okay, so So specifically with the Da Vinci robot, a lot of the controls are done by hand. The computer algorithms or AI that might be applied are really just for stopping, like say if my hands were kind of shaky, it's to just smooth out that movement, right? And so advances specifically in medical AI, not necessarily for robots. Like I'm not sure about AI applied to robots doing tasks for us, but I know of different programs that if you take a picture of, say, like something on your skin, it will tell you like, hey, this is a wart, or it is a mole, or it is sunburn or something. And so we can use this technology to help us determine and kind of give us diagnostic tools. But ultimately, right now, I don't think we're at the level where AI kind of makes decisions for us or does actions for us right yet.
We have time for one more question. So the last question for today is asking, how hard is college, or what do you recommend studying if our students want to work at Sandia?
Okay, so college is a little challenging for sure. I learned a lot of different subjects I had never known about. A lot of the subjects will describe to you the basic theories and equations that show how these like items are reacting. Like if you go to college and you take chemistry, then you'll actually learn the reactions and the ions and the stuff that's going on between the chemicals and stuff like that. But if you do want to work at Sandia, then just start to like read more about science, technology, or engineering, or math. Like any of those subjects are really well like rounded, and people all over the world want them, not just here at Sandia. But if you do want to work here, then try to study up on science and math, and then when you get to college, you can try to focus on a more direct discipline. So I personally did aerospace engineering for my undergrad, and then I went and got a master's in mechanical engineering, and now I work at Sandia. But a lot of people do degrees in chemical engineering, computer science, electrical engineering. Those degrees can help you out as well.
Great. And for anybody who's watching, this presentation is being recorded on YouTube, so you'll be able to access it later if you wanted to rewatch some of the experiments Alex was doing. But otherwise, Alex, thank you so much. Thanks for being here. That was a total hit. I think the students really got a kick out of it.
Well, thank you. I really enjoyed you guys' question, and I really enjoyed being here with you.
Awesome. All right. Well, thank you, Alex. Don't forget today, if you're watching on YouTube at 1 p.m. today, we have Fidelity. They're jumping on to talk about why save, right? Why save and how, it's so important to save, and just some really awesome things like that. Fidelity always does incredible presentations. And if you visit our website, discoveryfestnm.org, you can take a look there, and they have some PDFs and some things that you can download and kind of see what they're going to be talking about today. So if you're in middle school or older, this is a great presentation for you. So be sure to check that out. Finally, I think that's just about everything we have for you here. We wanted to give one final thank you to our sponsors for this Discovery Festival. That what we're doing here would not be possible without these wonderful folks. Honeywell, Fidelity, again, who's coming on today, Aztec Machine and Repair, Air Force Research Laboratories, Defense Threat Reduction Agency, Micronet, Presbyterian, Sandia National Labs. Thank you so much to all of our sponsors for this event. And thanks to all of you for watching. We will see you today at 1 p.m. for Fidelity Investments. Stay safe, stay healthy. Bye, everybody.